Hello, welcome to our video solving trigonometric equations, specifically this time with the t formula. So not much else to say, let's get started. Okay, example number 1. Solve for sine x plus 7 cosine x equals 3, and we're going from 0 to 2 pi. Now this one here we could solve using the auxiliary method, so that's open to you, but today we want to practice the t formula. So whenever we are doing one like this, the first thing is we want to should always write this, let t equal to tan, in this case, x over 2. And if we do that, we want to show our substitution. So then for sine is 2t over 1 plus t squared plus 7. Cosine is 1 minus t squared over 1 plus t squared equals 3. Okay, and then we want to expand the brackets, and we have the common denominator, so I can actually get rid of those fractions by multiplying everything by 1 plus t squared. So I end up with 8t plus 7 minus 7t squared equals 3 plus 3t squared. Okay, group all your like terms together. It's a quadratic we have here, so we want everything on the same side and 0 on the other side. So 10t squared minus 8t minus 4 equals 0. So quadratics we could sometimes factorize. This one we can't. So we will use the quadratic formula. So it will be negative b. So negative 8 makes positive, plus or minus square root of negative 8 squared minus 4ac all over 2a. And then I get my solutions for t. I've got negative 0.3483 and 1.14833. Okay, so now we want to substitute back in. So tan x over 2 can be minus 0.3483, and I can do inverse tan to find that. Make sure you never round until the very end. Now, as my base angle here, so my inverse tan, I get minus 0.334. But that will not be within the domain that we have from 0 to 2 pi. So tan has a cycle of pi, so we just add pi until we get to where we want. So x over 2 is pi plus the negative 0.334, and then I need to multiply by 2, so I get 5.61. Okay, now that's just one solution. I also need to do tan x over 2, 1.148. So x over 2 is inverse tan of 1.148. And then my base angle there is 0.854. So that one's actually already in our domain, so I can just times by 2, so it's 1.71. So 2 solutions. Okay, example number 2, we have solve 2 cosine x minus 8 sine x equals 5, and we're going from 0 degrees to 360 degrees. So remember, first thing with a t formula question, we want to let t equal tan x over 2. Okay, now we can make our substitution. So let's show that. 2 cosine is 1 minus t squared over 1 plus t squared minus 8. Sine is 2t over 1 plus t squared, and that equals 5. So same as the last example, we can multiply everything by the denominator there and expand our numerator. We'll end up with 2 minus 2t squared minus 16t equals 5 plus 5t squared, bring everything together. 7t squared plus 16t plus 3 equals 0. Okay, can't factorise this one again. So quadratic formula will be negative b plus or minus b squared minus 4ac all over 2a. Okay, so we end up with two solutions here. T is negative 0.206 and t equals negative 2.0996. Okay, and now we want to substitute back in. So we end up with tan x over 2 is negative 0.206 and inverse tan okay, and we get our base angle. So base angle for here is, this is in degrees, so negative 11.64. Obviously that's not in our domain, but tan's a nice and easy one because all we need to do is add pi, or in this case add 180 degrees to that. So we get x over 2 equals 180 minus 11.64 and multiply that by 2. So we get 336.71 degrees to two decimal places. And let's go over to the other one. So tan x over 2 is minus 2.0996 and inverse tan. It's the same as we just did. And that is a base angle here was negative 64.31. Okay, so same deal, we want to add 180 to that and then times by 2. So our x is approximately 231.36 degrees. Okay, third example today is solve 3 sine x minus cosine x equals 1 from 0 to 2 pi. Okay, so we always start the same. Let t equal tan x over 2. So we end up with 3. Now I can do my substitution. Sine is 2t over 1 plus t squared, and cosine is 1 minus t squared over 1 plus t squared equals 1. Same as we did last time. Just be careful, that's a negative, and the negatives, that's actually going to make a positive. It's going to be plus t squared, and this will be 1 plus t squared. T squareds cancel. 6t equals 2, t equals 1/3. Tan x over 2 is 1/3, so x over 2 is inverse tan 1/3. Okay, and then x over 2 is 0.3217, and we just double that. But you might be thinking, well, why do we only have one solution? The last two examples that we just did, that they both had two solutions, and now we only have one. Now there's a reason for that. In the previous two examples, I haven't, but we should have been checking that x equals pi, checking whether or not that is a solution in our original equation. Okay, now in the first two examples we got away with it. I actually knew already that they weren't, but in this one here it's a pretty clear indication that maybe we should check this one because we have only ended up with one solution. And the reason why we need to check is because tan x over 2 is undefined at pi. So let's check. Left hand side would be 3 sine pi minus cosine pi, which is sine pi is 0 minus, and cosine pi is -1. And so if I subtract -1, I get a +1, which is my right-hand side. So therefore, x equals pi is a solution. So I have 2, it's 0.64, and pi. So I left that example for the last, but always make sure that you check the solution x equals pi, and the reason is because we have our original equation has sine and cosine, and we are using tan to solve that, and tan is undefined, or tan x over 2 is undefined at pi, so we have to check that. Okay, last example today is solve tan theta plus 3 cosine theta equals 2 from 0 to 360 degrees. We're actually not going to solve this one, but we're going to talk about why we wouldn't. And you might have noticed that the first 3 examples all had sine and cosine. This one's got tan, and we could solve it, but it's going to be hard for us to do it algebraically because tan is 2t over 1 minus t squared, and cosine is 1 minus t squared over 1 plus t squared equals 2. And the reason is because our denominators are different. So we would have to find a common denominator, and that's going to actually result in a quartic. Whereas if we have sine and cosine, they already have a common denominator, and we had a quadratic, and we know how to solve a quadratic. So very hard for us to solve algebraically, but think about other methods that we've learned, like solving graphically. We could do that to help us solve one that involves tan. And that is it for this one, guys. So just remember some important things. Always make sure you write down what you are doing. If you're using the T formula, write down that substitution. Show the substitution before you start solving. And always make sure when you're at the very end, make sure you check that x equals pi, whether or not that is a solution, because we know our tan x over 2 is undefined at that point, so we really need to double check. Now make sure you smash your computer and subscribe, and then add a notification to get the bell, and I'll see you in the next video.